conic sections. There are a few different types of conic sections. The ones that we're going to focus on today, at least in this video, is going to be ellipses. And before I jump into ellipses, I want to talk about circles. So a circle, if you imagine, so with these cones, right? If I took a plane and I cut through the cone perpendicularly to, say, imagine that there's an axis point that runs straight vertically through this, we would have a circle. Well, the equation of a circle, which you already know, is x squared plus y squared equals radius squared. Now that's a circle. If the circle is not centered like at the origin of a coordinate grid, then we would change the equation of a circle and it could or would look like x minus some constant, we'll call it h squared, plus y minus a constant k squared equals radius squared, where h and k is the center of the circle. So h and k being 0 would produce this equation. But if h and k, the center of the circle, being somewhere not 0, 0, then this is the kind of the standard form that we would like to see. Okay, now I'm going to go one step further here. Let's suppose that plane that, before, that would make the circle, if we slant it and it slices a cone, it will create what you see here in red, right? See that red shape right there? That is an ellipse, okay? When we have an ellipse, the equation format changes, okay? It's not a circle anymore, so it's going to be different than what you see above. We are going to focus today on what the equation looks like in standard form for an ellipse. Okay, what does a standard equation look like for an ellipse? Now, we remember the one that was a circle, and if you look here, this is very similar to a circle. The difference is the denominator here, okay, and that it's equal to 1. So it's still an x squared piece and a y squared piece added together. It will equal 1, and they both have denominators that are not the same. If the denominator was the same, in other words, if a squared and b squared were the same, you have yourself a circle, not an ellipse, okay? All right. So this top one, you'll notice the a squared is underneath the x squared piece. This one, the b squared, is underneath the x squared piece. That is what we're going to use to identify whether or not this ellipse is elongated horizontally or vertically, okay? So what's a squared under? When the a squared is under the x, then this one is going to be elongated horizontally. In other words, this major axis that runs through it is parallel to the x-axis, okay? All right, now down in this next one, the a is below the y squared piece. That's going to be elongated vertically, where this major axis is parallel to the y-axis. I know that it says it's on it, but that's only because our center is at 0, 0 for these two examples, okay? So here's our two pictures. I'm going to go through and I'm going to point out a few things on our pictures. The first one, obviously, left is horizontal. The right one is vertical. Excuse me. A is the distance from the center to the vertice. So center to the vertice is A units. Okay, right there. Now, you could count it out to this vertice. That distance would still be A. All right. C, I'm jumping to C now. You don't have a C in the equation that you saw. Standard form didn't have a C in it. But those focus points that we looked at before, the distance from the center to the focus points, that is a length of C units. Okay? The B, which is in the equation, is the distance from the co-vertice, so in other words, the short width, to the center. Okay. Now, here's the craziest thing, and it's very interesting. A, B, and C do have a Pythagorean relationship. If I picked up that A length and I dropped it, it would fit right there. Meaning there is a Pythagorean relationship, except A is the largest, not C. Okay? They write it this way. If you're a student of mine, I'm going to give you a formula sheet. Okay? The center is HK. Now, remember when we had that conversation about circles, how we had that H and K? If there's numbers in those spots, we're shifting it. So it's not at 0, 0, it's somewhere else, okay? A is underneath the X piece if it's elongated horizontally. A is underneath the Y piece if it is elongated vertically. In other words, that major axis is parallel to the Y-axis or the X-axis, depending on, okay? All right. So for this ellipse conversation, so for this section, for this video, we're going to be focusing our attention on this highlighted information. All right, and I like to kind of sketch them as I go so I have a mental picture of what's going on. So for this first one, what is the standard form for an equation of the ellipse that has vertices at 8, 0 and negative 8, 0. So what they're saying here is here, 8, 0, and here, negative 8, 0. Those are my vertices. I know by just looking at this that this is going to be an ellipse that is elongated horizontally, okay? If it's elongated horizontally, the form that I'm working with is going to be x minus h squared over a squared plus y minus k squared over b squared, and this will equal 1, okay? Now, we know that A, remember, if you need to go look at a formula sheet, A is the distance from the center to the vertices. So I know if this is my vertice and this is my vertice, well, halfway in the middle is going to be my center. So I know my center is at 0, 0. And I know A is 8 units. Okay? We'll have a B and we'll have a C. I also know the foci, and it's telling me that the foci is 5, 0 and negative 5, 0. So there's a foci and there's a foci. So 2 vertices, 2 foci. All right. Let's work on distance from from center to foci. That is 5 units long, right? So that's C. What I don't know is B. If I want the equation, I need to know the B value. Well, I'm going to do some side work and do the Pythagorean theorem, except A is the largest. So 8 squared is equal to B squared plus 5 squared. So 64 minus 25 gives us 60, 40, 39. Ew. So B is the square root of 39, which is approximately 6.24. Oops. All right. So let's go back to the equation now. HK is the center. So my equation is going to be x minus 0 squared over 64 plus y minus 0 squared over 39 equals 1. And there's the equation for that. Okay? All right. I'm going to jump in and do some other examples in the next video. So stay tuned.